Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we explore the growing concern surrounding the North Atlantic's mysterious cold blob and what it could reveal about the future of global ocean currents. At the center of the debate is a region that has puzzled researchers for decades. Scientists have discovered a strange anomaly in the North Atlantic, situated south of Greenland, where a cold blob of ocean and air is cooling down while the rest of the world is experiencing a rise in temperature. Researchers used satellite data, multiple reanalysis records, and ocean heat content data extending back to 1955 in order to figure out the driving forces behind the blob. Up to this point, scientists have long debated two possible causes behind the Atlantic Ocean's cold blob: either reduced heat transport into the region by ocean currents or increased heat loss from the ocean surface. The latest findings support the former theory, suggesting results support the first explanation, and they conclude that we're now very close to a dangerous tipping point. The study links the cold patch to a weakening of the Atlantic Meridional Overturning Circulation, or AMOC, a major ocean current system that appears to be edging closer to a potential collapse. Researchers warn that such a shutdown could have far-reaching global consequences beyond the cooling observed in the North Atlantic. Given the well-established existence of a tipping point of the AMOC, as well as recent studies finding a range of different early warning signals of the ocean circulation approaching such a tipping point, the strong evidence for a weakening AMOC is a serious concern for society and policy, the researchers wrote in a published paper. Their analysis found that the cooling is driven by changes in deep ocean currents rather than heat escaping from the surface. In fact, surface heat loss in the region has declined, indicating that the main issue is a reduced inflow of warm water. Because the cold blob lies at the northern end of the AMOC's vast ocean conveyor belt, a slowdown in the system would naturally result in lower temperatures there, as less warm water is transported northward from tropical and equatorial regions. The new findings give us a few of the best pieces of evidence yet that the cold blob and this vast ocean current are directly interconnected. The observed cooling trend cannot be explained by surface heat flux changes, write the authors of this new study. Multi-decadal heat content variations are generally larger and more tightly correlated with ocean heat transport than with surface heat flux variability. Most scientists agree that the Atlantic Meridional Overturning Circulation, AMOC, is gradually approaching a critical point and could eventually cease functioning altogether. Rising ocean water temperatures, coupled with melting glaciers, which release fresh water into the oceans, are disrupting the balance that drives the current system. A complete collapse of the AMOC could trigger far-reaching impacts, including much colder, harsher winters, with significant changes in global weather patterns, ecosystems, and food security across Europe. While large uncertainty remains over how close the Earth is to this tipping point, standard CMIP6 simulations of future global warming scenarios suggest it is crossed in a substantial subset of these model simulations around the middle of this century, write the researchers. Since 2004, the current system has been directly monitored, leaving scientists with a very small record to clearly find out the long-term trajectory of its recent weakening. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.